Welcome to our tutorial on building real-time React apps using WebSockets. So, you've got a React app and want it to be as responsive and interactive as possible? That's where WebSockets come in. Think of them like a continuous open line of communication between your server and client. Instead of making frequent requests with HTTP, WebSockets allow for real-time data exchange. For example, imagine an online chat application. Messages are sent instantly without needing to reload the page. We'll show you how to set up WebSocket connections in React, send and receive messages in real time, and handle events efficiently. Let's dive into this exciting world of real-time web development. Welcome to our tutorial on WebSocket technology and how you can integrate it into your React real-time applications. First, we'll start by understanding what WebSockets are. Essentially, a protocol for full duplex communication channels over a single TCP connection. Next, I'll guide you through setting up a basic WebSocket server using Node.js. Then we'll dive into integrating this technology directly into your React application to enable real-time data updates. We'll explore how to handle these live data streams effectively and ensure your app performs well even under heavy load. Additionally, we'll cover best practices for managing connections and errors in production environments to keep your application stable and responsive. Welcome back to our tutorial on building real-time applications in React. Today, we're diving into the world of WebSockets. So what exactly are they? WebSockets is a protocol that allows for full duplex communication over a single TCP connection. This means you can send and receive data simultaneously without needing to constantly poll or use long polling techniques. Perfect for applications where real-time updates are crucial, like chat apps or live sports scores. The beauty of WebSockets lies in their ability to maintain that persistent connection until it's explicitly closed, ensuring a smooth, low-latency experience for your users. So if you're looking to add real-time functionality to your React app, WebSockets might just be the perfect solution. Alright, let's dive into setting up our WebSocket server using Node.js and Socket.io. First, we need to install the required dependencies for our web application framework and for handling real-time communication. Here's how you do it. Run this command in your terminal: npm install express socket.io. Now let's take a look at the code. We import Express, HTTP module, and Socket.io. We create an Express app and use it to create our server with http.createServer app. Then we initialize Socket.io on our server. When someone connects, we log a message saying a user connected. And when they disconnect, we log user disconnected. Finally, we start the server listening on port 3000. This sets up the foundation for real-time communication in your React app. Pretty straightforward, right? Let's get coding. Alright, let's take a look at what happens when we run our WebSocket server. First, you'll see the terminal output when we type npm run start or simply node app.js. The server begins and listens for connections on port 3000. When a new client connects, the server logs a user connected to the console. So if everything is working correctly, you should see server is running on port 3000 and a user connected. This output confirms that your WebSocket setup is functioning properly. Remember, this is just the first step in setting up real-time communication between a client and server using WebSockets. Welcome to our next slide. Today, we're diving into integrating WebSocket functionality in a React component. Let's break down the code on screen. First, we import React and UseEffect from the React library, and then we bring in Socket.io client for handling WebSocket connections. We create a new WebSocket connection to http://localhost 3000. Inside our real-time app function, we use UseEffect to listen for incoming messages when the component mounts. When a message arrives, it gets logged to the console. And here's the neat part. If the component unmounts, we ensure that the socket disconnects properly to clean up any resources. This is how you set up real-time communication in your React applications using WebSockets. Ready to see this live? Let's test it out together. Welcome to our tutorial on handling real-time data updates in React applications using WebSockets. To start, we use to listen for specific events from your WebSocket server. This lets you know when new data is available. For example, if a user submits a message, the server might send an event with that message. In our React component, we then dispatch actions based on this received message, like updating state or triggering some UI changes. To make sure everything cleans up nicely, especially when your component is about to unmount, use for any necessary cleanup tasks. This ensures your application remains efficient and doesn't leave behind any lingering connections. Let's dive into the code examples next to see this in action. Welcome back. Today, we're diving into an important topic in real-time React apps that use WebSockets. Let's start with the bad approach, no cleanup function in your. Imagine you have a WebSocket connection set up, and when the component unmounts or re-renders, the socket doesn't get properly closed. This can lead to memory leaks and unexpected behavior. Now, let's look at the good approach, using a cleanup function within your to ensure that on unmount, you properly disconnect from the WebSocket server. For example, say we have a chat application. When the user leaves the page, the connection is safely closed, ensuring no lingering sockets and keeping our app efficient and responsive. Remember, a well-managed WebSocket ensures smooth real-time interactions without any hiccups. Alright, let's dive into today's quiz question. Imagine you're working on a real-time app using WebSockets in React. Now, what happens if you forget to use the hook? Well, first off, your WebSocket connection won't be properly cleaned up when the component unmounts. This means that even after you navigate away from the page or close it, the connection might still linger in memory. And this can lead to something we call memory leaks, basically, resources being held by the app without any way to release them. It's like leaving a door open when you should be closing it. Plus, with each unmount and remount of your component, you could end up creating new WebSocket connections unnecessarily, which is not only inefficient but can also consume more server resources. So, always remember to use to clean things up properly. In our WebSocket setup, error handling is crucial to ensure smooth communication. Let's look at the code on this slide. We use to handle any errors that might occur during the connection or data exchange with the server. When an error happens, we log it using. For example, if there's a network issue, you'll see something like error, connection lost in your console. Next, let's add some cleanup for our WebSocket component. We wrap this logic inside a hook to ensure the socket disconnects when the component unmounts. This prevents memory leaks and keeps our app clean. When the component is about to unmount, we call to properly close the connection. That's it for error handling in WebSocket with React. Alright, let's dive into how our error handling code behaves. When an error happens, we log error, which helps us pinpoint the issue quickly. On component unmount, it logs disconnected from server, ensuring we know when our connection is lost. Now, looking at this piece of code, this line sends an event named SomeEvent with some data to the WebSocket server. But here's where things get interesting. We simulate an error using. When this unhandled exception occurs, our code catches it and broadcasts a custom error event to the server with the error details. This setup ensures we're always aware of any issues in real time, making debugging easier and our app more robust. Hey there, welcome back. Today, we're diving into best practices for production when building real-time React apps using WebSockets. First up, let's talk about environment variables. These are super useful for managing settings like API keys or database connections without hard-coding them directly in your app. For instance, you might have a that changes between development and production environments. Second, robust error handling and logging are key. They help you catch issues early and keep track of what's happening in your application. Imagine logging every WebSocket event, like a user connecting or disconnecting, and reacting to errors gracefully. Lastly, caching responses can save you from hitting rate limits. For example, if you're fetching data frequently, caching it locally can reduce the number of requests you send out. These practices ensure your app runs smoothly in production. Rocket. Welcome back to our series on building real-time applications in React. Today, we're diving into the power of WebSockets. They allow your client and server to communicate instantly, like sending a message or updating data on the fly. For setting up WebSocket servers, Node.js with Socket.io is a game changer. It's incredibly easy and comes packed with features. When integrating in React, you'll be listening for events like new messages or disconnections, ensuring your app stays connected. Don't forget to handle errors gracefully and use caching for performance. And as always, follow best practices. Use environment variables for security and proper logging for debugging. Let's make sure our apps are robust and responsive with WebSockets. Welcome back, everyone. Today, we're diving into why using environment variables is crucial. First up, let's talk about security. Imagine your app uses WebSockets for real-time updates. Hard-coding sensitive credentials like API keys or database passwords directly into your React code could be a major no-no. This makes it easy for anyone to steal this info just by looking at the source code. Instead, we use environment variables to store these secrets securely outside of our codebase. Secondly, think about flexibility. What if you want to deploy your WebSocket app on different servers with varying configurations? By keeping settings like server URLs or port numbers in environment variables, you can easily switch between environments without changing a single line of application logic. That's the power of separating config from code. Welcome to our tutorial on configuration management in React real-time apps using WebSockets. Let's start by looking at the wrong way, hard-coding your credentials directly into your application code. This is a big no-no. If anyone gets access to this code, they can see all your sensitive information right there. Now, how do we do it the right way? We use environment variables instead. For instance, if you're setting up a WebSocket connection, you define your server URL and other settings in your file or through an environment manager like .env. This keeps your credentials safe and secure. Plus, it makes it easier to switch between different environments like development, staging, and production with just simple changes to your environment variables. Welcome back, everyone. Today, we're diving into the world of real-time applications using WebSockets. WebSockets are key for creating dynamic and interactive web apps. But integrating them with React isn't just about setting up a connection. It's also about handling errors gracefully, managing disconnections properly, and optimizing performance through caching. Let's break it down. First, ensure your WebSocket setup works seamlessly with React components to keep the client and server talking smoothly. Next, implement robust error handling to catch any issues quickly. Then, manage those disconnections so that users stay connected even if the connection drops for a moment. Lastly, use caching strategically to reduce latency and improve overall app performance. By following these steps, you'll build real-time apps that are not only responsive but also reliable.